Welcome to Mr. Chalk's Revision Tips. In this video, we will look at the birth of a star, the life of a star, and the death of the star. So, a star's life cycle is determined by its mass. So, as the main sequence star grows, hydrogen in its core is converted into helium by nuclear fusion. When the hydrogen supply in its core begins to run out, the star will no longer be generating heat by nuclear fusion, and the core becomes unstable and contracts. So if we're looking at how a star starts, we start off with a nebula. So something causes the nebula to be squeezed together. Squeezing made the clouds start to collapse as gravity pulled the dust and the gas together, forming a solar nebula. It began to spin faster, and most of the cloud begins to flatten, and you end up with a mass in the center of the disk. So if we look at, as the particles move closer together, what does this cause? Well, they get hotter because they're increasing in friction, and the pressure increases at the center. So once a cloud of gas has become suitably hot and dense, fusion will occur within and the star is born. So astronomers claim that there are about 300 billion stars in the Milky Way. So we're looking at describing how it was formed. Key things that we need to talk about is the fact that there needs to be enough gas or dust that are pulled together by gravitational attraction, and when the pressure and the temperature are high enough, nuclear fusion can take place between the smaller elements to form larger ones, releasing energy in the process. Stars are formed by these massive clouds and dust, so gravity pulls the dust and gas together to form a protostar. As the gases come together, they get very hot, so the outward pressure from the expanding hot gases is balanced by the inward pressure caused by the star's gravity. So, as part of its life cycle, a star changes from being a protostar to a main star. If we're looking into explaining the difference between these, the key things is that a protostar is at a low temperature. A protostar does not emit radiation or energy, and nuclear fusion reactions have not started in a protostar. And if we're looking to explain the forces acting within a main stage star, the key things is that the outward force caused by fusion is equal to the inward force caused by gravity. Once the hydrogen runs out, the fusion stops and gravity takes the lead and compresses the star smaller and tighter. Temperatures increase with the contraction and eventually reaching levels where helium is able to fuse into carbon. So the energy produced by the helium fusion causes the star to expand to many times its original size, as now the outward force of fusion is greater than the inward force of gravity. So outward radiation and gas pressure forces are balanced by gravitational forces usually. So when the inward gravitational forces are less than the outward radiation pressure forces, the star swells and cools, thus turning red. The high mass stars become red supergiants, low mass stars just become red giants. If we look at how some stars end then, so small stars like our Sun will undergo a relatively peaceful and beautiful death that sees them pass through a planetary nebula phase and become a white dwarf. So we look at this question. So brown dwarf stars are thought to have been formed in the same way as other stars. They are too small for nuclear fusion reactions to take place in them. So brown dwarf stars emit infrared radiation but are not hot enough to emit visible light. So if we're looking at describing how this star was formed, same as we were talking about before, you'd still have to have enough gas and dust that's probably come from some sort of nebula that's been attracted into a mass in the centre by gravitational attraction. If a red giant is massive enough, it may eventually rapidly contract and bounce off the core and then explode. Right, and this is called a supernova. One hydrogen fuel used up by the star, it will expand and become a red giant. It will then contract under gravity and become a white dwarf, and as it explodes, it will throw out lots and lots of the dust and gas into space. So Mira is a massive star, so explain why the Sun will not go through the supernova stage, but Mira will. So the key things are that only very massive stars can become supernovas. So Mira is large enough, but our Sun is too small. So the Sun is too small to give it a supernova. However, Mira is large enough to go and cause one. If we're looking at neutron stars, so as the star collapses and then explodes in a supernova, the core of the star is crushed down into nothing but neutrons. The densities of these neutron stars are even greater than those of white dwarfs. And if we're looking at the ending for massive stars, they can go and form black holes. So if enough matter is left behind in a neutron star, it might be so dense and the gravitational field is so strong that nothing can escape it, not even light or EM radiation, and thus it will become a black hole.
Thanks for watching.